Hello folks, and welcome to question number 2 on the 2018 AP Calculus free response. This is a calculator allowed question. It is also a motion problem, and with any motion problem you want to keep in mind the relationship between position, velocity, and acceleration. So very quickly, let's just go over those relationships. Position, it is represented with x of t and sometimes with s of t. When we derive position, we have velocity, which is really speed with direction. That is the first derivative of position, and it is represented with v of t. When we derive velocity, we have acceleration, the change in velocity. That is going to be the second derivative of position, the first derivative of velocity, and it is represented with a of t. So knowing that, let's continue on to problem number 2. A particle moves along the x-axis with velocity given by v of t for time t is greater than or equal to 0, less than or equal to 3.5. Right away, this is the function that you should store into y sub 1 on the calculator so that later on in this question you don't have to keep writing this function out or keep plugging it into the calculator. The particle is at a position x is equal to -5 at time t is equal to 0. This would be your initial position. You always want to mark the initial position so that you don't forget about it later on. Part A, find the acceleration of the particle at time t is equal to 3. Now, in this question, we're given the velocity function. We wrote in the beginning that when we derive velocity once, we get acceleration. And you want to show the reader that you understand this relationship between velocity and acceleration. And you do that by first writing a of 3 representing the acceleration of the particle at time t is equal to 3. And equal this to v prime of 3. This will show the reader that you understand the relationship between acceleration and velocity. This is really all you have to write. Let the calculator do the rest of the work for you. Go to Math 8 and put in y sub 1 evaluated at 3, and this should give us the answer of a negative 2.118 rounded to 3 decimal places. That is again the acceleration at time t is equal to 3. And we're done with letter A. Moving on to letter B. B, we have find the position of the particle at time t is equal to 3. Because we're given the velocity function and we're looking for position, we have to go backwards. We have to antiderive velocity in order to get back to position. There is an initial position of -5. So with these type of problems where you have to antiderive, your final position will always be equal to the initial position that's given to us, and hopefully you underlined in the beginning of the problem, plus the displacement or net change in position, which is really the antiderivative or the integral of velocity from A to B. This is your displacement. In the context of this question, our final position, what we're really looking for is the x value when time t is equal to 3. Right? Notice here that the input is time and the output is x, which is position. So this is equal to the initial position of -5 plus the displacement. And what you want to put on your integral is the initial time, which is 0, up to the time that we want to find the position of the particle at. 0 to 3, v of t, you don't have to copy the function, just simply write v of t because it is already defined in the question, and close it off with dt. The right-hand side of this equation is what you should input into the calculator, and when you do so, it will return an answer to you of -1.760, and that is the position of the particle at time t is equal to 3. That is all for B. Moving on to letter C. C says, evaluate the integral from 0 to 3.5. Be careful here with the upper limits of integration of v of t dt, and also evaluate the same integral except there are absolute values around this v of t function. Interpret the meaning of each integral in the context of this problem. Well, the first thing that we have to do is to use Math 9 on the calculator and evaluate both of these integrals. To get the absolute value on your v of t, we have to go to, if you have a TI-84, That would be math. On the top, num, and press enter on number 1, abs. This will put in the absolute value around the v of t. Once you do so, the answer to your two integrals will be very different. The first one, without absolute value, we have 2.844 rounded to 3 decimal places and 3.737 with absolute value around the v of t. What do those integrals mean? Well, the first integral we have already discussed in part B. This is really the displacement or the net change in position. And on the free response, you would just rewrite this integral again and say that this integral represents the displacement of this particle. And make sure you give a time frame on the interval where t is less than or equal to 3.5 and greater than or equal to 0. With absolute value, the integral from 0 to 3.5 of the absolute value of v of t dt, this means something else. This is the total distance. And in this case, we do take into account all the distance we covered, even when we're going in a negative direction. We count those as a positive value. Total distance, the particle travels. And again, you want to put the interval on which this happens. T is less than or equal to 3.5, greater than or equal to 0. So just remember, with absolute values around the v of t, the integral would be the total distance. Without the absolute value, it is the displacement. Letter D. A second particle moves along the x-axis with position given by x sub 2 of t is equal to t squared minus t on the same time interval. At what time t are the two particles moving with the same velocity? The word same should spark in your mind the equal sign. Same velocity means that the velocity of particle 2 is equal to the velocity of particle 1, which was already given in the question. In other words, at what time does v of t equal to the derivative of x sub 2 of t? And on the side, make a note to the reader and to yourself that you understand the relationship between position and velocity. When we derive the position of particle 2, we get the velocity of particle 2. Now, the derivative of x sub 2, that is going to be 2t minus 1. So we want to set the original velocity of particle 1 equal to the velocity of particle 2, which is 2t minus 1. This equation is easily solved on the calculator by using equation solver. And if you're using a TI-84, using equation solver, you want to make sure that this whole equation is set up equal to 0. And we can do that by subtracting v of t from both sides. So v of t cancels. We have 0 is equal to 2t minus 1 minus v of t. So you just want to type in the right-hand side of this equation into equation solver, where y sub 1 represents the velocity function that we have stored already. And once we solve for t, the calculator will hopefully return to us 1.571 rounded to 3 decimal places. That would be the time at which the two particles are moving with the same velocity. And that is all for question number 2 from the 2018 AP Calculus free response.